and I think it is time to take the quiz. And then after we finish everything, finish all these 4 lectures, and then finish the lab 3, we can have our exam. When do you want to take the quiz for TLC, which is a quiz 2 for our mechatronics? I want to know.
Next Wednesday.
Huh?
Next Wednesday, maybe.
Next Wednesday? Next Wednesday is okay? Next Wednesday, and I will give you 24 hours. Okay, it's a quiz, it's a quiz. You understand, guys? Quiz is a quiz. Quiz means that it is informal exam. And I also look at the feedback. The feedback, some students say that the exam is kind of long. But however, you know, for this class, because the nature of this class, we do not have too many homework assignments, right? And we focus mainly on the hands-on experience. But we only have 3 quizzes, 3 exams. These 3 exams included the final exam. So if you think the exam is still very long, I can shorten it. But how can I evaluate the outcome, the learning outcome? Right? So if you think the exam is long, I can give you more time. And let's finish our quiz 2 first. Then when we talk about the exam 2, and we will talk about this in detail. How does that sound? Okay. So without further ado about quizzes and exams, I'm going to make an announcement. And after I finish this class, we are going to continue. I'm going to continue our talk about the PLC. Now, up to now, we have learned the PLC fundamentals. We have learned how to address PLC, all the bits. Especially now, you have the hands-on experience already. And then we also have talked about the timer on, timer off. We also talk about counter down, counter up. Now today we are going to talk about the program control instructions. So keep in mind, the PLC, it is a specialized computer. Specialized computer, that means this guy has some language, right? This language. We have MATLAB language, we have C++. But for the PLC, this guy's language is called ladder logic diagram. And we still call it is a language, programming language. Now this time we talk about if you have any experience of the programming language, and you know that syntax, there's some syntax about, for example, C++ syntax for C++, and how to control the program. And here is the same. And now how to control the program. So as I said at the very beginning, ladder diagram is just like the other programming language, and it is executed from the top to the bottom, from left to the right, right? So the same thing. And so now today I'm going to talk about how can we control. And so this is a diagram, exactly execution of the diagram. So here are today's objectives. We want to learn the MCR. MCR stands for the Master Control Reset. Master Control Reset instruction. This guy is the instruction. And we also learn the jump instructions. The jump JMP. The JMP is very funny. It looks like the Journal of Manufacturing Processes, for which I'm the associate editor. JMP. That's the reason when we talk about JMP, it resonated with me. Okay. So LBL label means label. What does that mean? It means that you can set you can write a diagram around if some conditions are met and you want to jump. Jump where? Jump to this label. Okay? If some conditions are met and I want my program to jump to somewhere instead of just execute the runs one by one. So this is jump label. They are used in pairs. Okay? If you use a jump, you must specify a label. Where do you want it to jump? Otherwise, the system will be messy. Second one, the subroutine instructions. And the GSR jump to subroutine, and the SBR subroutine, RET return to subroutine. So have you guys ever heard of or heard subroutines? Have you guys ever heard of functions? Huh? You heard functions. When you use MATLAB, C++, or other languages, and sometimes you need to write a function. What is a function, guys? A function means that you want to do something special, to do some specified task or tasks, right? In order to minimize the writing the statement, writing the program, and you want to just write a function. Whenever you want to do these kind of things, you call this function. Whenever you want to do these function tasks, you call this function. Instead of whenever to do this, I need to write all these statements here, all these statements here. If this is the case, the program will be very lengthy. That's the reason we use function. So here, the subroutine here is a function. Okay, can you write down this? Subroutine here is a function. So subroutine, based on my experience, when we call subroutine, when we call function, and for lower level language, we call subroutine. For higher level language, we call the function. It's the same thing. When I talk about higher level language, I'm talking about how close it is to our human language. For example, MATLAB. MATLAB is very intuitive. You guys agree? Very close to our human language. However, for the other languages, for example, for the machines, and for this is we use machine code, machine. This is binary numbers, and we call subroutines. So when you use the abacus is a higher level, but this guy will not call function, and this guy will call subroutines. Okay. Whenever you hear the subroutines or functions, you know that they are doing the same thing. They are doing the same thing. Doing what? And they want to do the specialized task or tasks. And if you want to do these kind of things, you just write a function or subroutine. Then, if there is a need in your main program, you just call this function or subroutine instead of when you need this one, you write all these statements there. When you need another next time, when you need to run this to accomplish this task, and then you need to write another bunch of the segments of these statements. Okay, with the function of subroutine, whenever there is a need, you just call it. This function will be saved separately. You understand, guys? Okay, subroutines are functions. They are similar. They are interchangeable. It depends upon which language you are using. So whenever we have a subroutine, okay, we'll call this function, call this subroutine. And how to call? We jump to there. Or in other language, we say call this program. Call this is the subroutine. Then this subroutine itself. In this subroutine, what I want to do. This is called subroutine. This is called function. Whenever at the very end of this subroutine, and you have a return. Return means that this subroutine is done. This function is done. Who has experience of using C++? Please raise your hands. Ready? You have some?
A little bit, yeah.
Okay. What's your name?
Drew.
Do you have C++ experience as well?
I use.
Yeah. If you use C++. Or we always have some return now, right? So call the function, this is a function body, this is function title, then function body. At the very end of this function body, you use return. You write a return. Then we learn about REF. MCR. MCR is very important, not just important for our PLC level 3, okay, and also important in our either quiz or our exam tool. What is MCR? Master. This is called master program control. And MCR is often called override instruction, providing a means of scanning a section of ladder diagram when specific conditions are met. It defines in a group of instructions that can be executed or disabled. So here is a run. Okay, here is a diagram. So this is left leg and right leg, and then we have multiple runs here. And so here this is run. Okay, so this is one run, and so this is another run. Between these two runs, suppose we have multiple runs, multiple other runs. So this is MCR. The first MCR is used as output, and second MCR is output also. For second MCR, we do not have any input instructions. Alright, but for the first one, we can have. If how the MCR works, I want you guys to know. Okay, because in our quiz or exam, and you need to use your own language to explain. So after I talk about one example, then I will let some guys come here to explain. And then first I ask you guys volunteer. Without volunteers, then I will call the call. Okay, pay attention. So what it says, if this condition is met, if this condition is true, if this guy is true, that means this condition is met. All the runs located in between will be executed as if there is no MCR. What? One more time. If this condition is true, or this condition is met, all the runs located in between these two MCR instructions will be executed as if there is no MCR. This is first part of my explanation. Second part. However, if this guy is false, if this guy is false, pay attention to what I say, okay? If this guy is false, the runs located in between these two MCR instructions for these retentive outputs will remain their status. However, non-retentive outputs will be reset. So outputs have two kinds of outputs, right? You guys agree? One is non-retentive. Non-retentive means that, so this guy is totally dependent upon the input. If the input is true, this guy is true. If input is false, this guy immediately false. So if this case, the output is called non-retentive. 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 Non-retentive, for example, this. So retentive. Retentive, and we have this L dash and this U. You understand, guys? Okay, let me repeat, okay? If this guy is false, within this segment, all these runs located in between, all the non-retentive outputs will be reset. That means no matter what kind of input instructions they have, they are reset. Because this guy is false. Right? However, the retentive outputs, they will still remain the status. So that's the reason this guy is called a master control. This is the instruction. Master control reset. The master, you know master, right? Master means we have master key. Master key means that this guy can open all doors. This master means that this guy can control all the runs located in between these two MCR instructions. So this is called master control reset. So you can see this is what I just told you guys. MCR instructions in pairs, they are used in pairs to create program zones. They call the zone, or this is the segment that turn off all the non-retentive outputs in the zone. You just make this false, make this guy's input false. Then you can control. You can just reset all the non-retentive outputs located in between. Runs within MCR zones are still scanned, but they are still scanned, but the scan time is reduced due to the false state of the non-retentive output. Still scanned, but will not do anything. MCR zones let you enable or disable segments of your program. So this guy give you flexibility. Whenever you want, if you want under some conditions, you do not want to execute these runs, or if some conditions are met and you want to execute all these runs located in between. So this gives you a bigger flexibility. When you program MCR instruction, know that, okay? You must enter the zone with the unconditional MCR instruction. So these two guys are always used in pair. One is the other, first one, second one, they must use in pair. And you cannot nest one MCR zone within another. Okay, you cannot nest one MCR zone in another. Otherwise, you will be confused. The system will be confused also. Also, do not jump into a MCR. And in the very beginning, when we talk about learning objectives, we will use jump on JMP, right? Whenever you use JMP, never jump to the MCR zone. If you jump to the MCR zone, because MCR zone it is controlled by this guy's input instruction or instructions, and so you will you'll be confused. The system will be complex. Understand, guys? Okay. Any questions regarding this slide? No question. So there is a example, guys. I'm going to talk. Then I will call one person to come here to explain. Okay. So here, I have this is MCR. This is first MCR instruction. The fence, we call it fence. The statement, the segment zone, or called fence start. This is my second one, MCR. So in front of the first MCR, I have on and off switch. So I can turn it on and off. And so here, first one is on high level float switch. So this is whenever you see this one, and whenever you see this bold, something in bold, that means this at this instant, this guy is true. Okay? You know that, right? Because in our PLC, later you just shook your head.
I didn't know that.
Huh?
I didn't know that. No, I didn't.
But when we do the PLC, the start-stop switching circuit, right? When after you finish this diagram, you turn the power on. The stop button, you see the stop button is bold green, right, guys? Bold green.
Our group,
Early, huh?
that didn't happen for our group, but I saw it with other groups.
You don't have in your group. That means your program is not right.
I mean, it worked fine, it just did not.
Or maybe I
show how it ran.
I think you did not notice. I think. Okay, whenever this guy is true, okay, it is bold. And for the starter button, if you do not click it, it just looks like normal. If you click it, you can see it immediately have this is bold green. Pay attention next time. Okay, so here that means this guy is true at this instant, right? This is true at this instant. So this heater is a non-retentive. Why? Because it's a full output. You understand, guys? It means that if this guy is true, this is turned on. If this guy is false, this guy will be turned off immediately. Okay. So next round is the CPU. CPU, right? Counter up. So counter up, counter down. Both of these two counters, and they are triggered by false to true. This transition. You still remember that? Okay. So whenever you click this button, so this counter will be triggered, and then after some time, this preset value 79 seconds. All the settings, I don't know why this guy used this number. 79 seconds. Then the 10 bit will be turned on. The 10 bit will be turned on. Okay. So this is a limit switch. So also here is the full output, but so this one limit switch 2. So this guy is connected to a latch. So this is a non-retentive. I'm sorry, this is retentive, and this is a non-retentive, non-retentive. So if this is all on and off switch is true, right? It's on and off switch is true. And all these runs located in between and will be executed as if there is no MCR. Everything going normally, just as usual. However, if this guy is a false, this is what I want to hear. If this guy is a false, what will happen? If this guy is a false, so this guy and this guy, and they are non-retentive outputs. Okay, non-retentive outputs means that if this guy is false, so this guy and this guy will be turned off immediately. You understand? If this guy this guy and this guy will be turned off immediately, then at the same time, no matter how you press this guy, you cannot turn this guy and this guy on. Why? Because this is a master control reset. You understand that? One more time. If this guy is a false, this non-retentive output and this non-retentive output will be turned off immediately. And no matter how you press these two buttons, you have no control. You cannot turn on these two guys. Also, at the same time, so this counter, and you cannot control this counter. This counter will not be triggered. However, for this guy, because this is a retentive, if this guy is turn off, so this guy will be still latch. Okay, this guy still latch. And no matter how you just do it, that guy still latch. So I'll give you 1 minute and for you guys to think about what I just said. 1 minute, okay? I'm going to count. Then I'm going to ask for a volunteer. If there is no volunteer, I will call one guy to count. As I said, if you come here, explain everything well, and I will write down your name. And finally, if you get A minus, and then I will bump you with A. But if you get A, I will bump you to A plus. No, I cannot. Practice one is A. I tell you one story. I have one student, very, very wonderful student. I don't know whether I told you this story or not. A very wonderful student. Okay, everything is good. Homework, projects, everything is done excellently. I give this student A. After some time, after I posted this final grades online, so this first student came to my office, say, I want to talk to you about that. I would say, yeah, well, I thought this person wanted to do some projects with me, or because this person is so wonderful. And he told me nothing, and I will not tell the detail. This student asked me, Mark, can I see my all the grades, homework, projects, everything? I said, yes, you can see. I said, you are a really wonderful student. That's the reason I give you A. Then he said, no, this person said, I told him, why you do not give me A plus? If you just told me I have done everything well, why do not give me A plus? I laughed, okay. I cannot give you A plus. This is our system, right? A is the highest one. But yeah, this is very interesting. I'll tell you, A is the highest one I can give. Who is ready to come here to tell us how this diagram works? Okay. Your name is
Richard.
Richard, okay. Yeah, tell the whole class and how this MCR works. That means what happens if the input instruction is true, and then what happens if the instruction input instruction in front of MCR is false. The two case scenarios.
So this switch is in the on position. Be unlike heads up display, you got a physical button and it's positive, or you got a positive input coming in from whatever that it's connected to. And the MCR is going to be true, so all these rows are going to operate as expected, or as if these MCRs weren't even here. So like activate this switch. If this switch gets activated on this rung, the heater's going to trigger. The stop push button's activated or deactivated. That's going to cause the count up to register for the countdown. Same for like limit switch, and I'm not sure what that is. But then if this switches to the off position, triggers an override, so that regardless of what these inputs are right here, that's going to be activate. That's going to behave as false. It's going to be deactivated. That's going to behave as false. That's going to behave as off. Correct.
That one is retentive.
Mm-hmm.
That L is retentive. L will be staying in the status will be remaining the same, remaining the same.
Okay.
That's good. Wonderful.
Good. All right.
Richard, thank you very much. I will write your name. Okay.
Excellent.
Okay. Any questions?
So for the count up and the done bit, so those are non-intensive like outputs. So when it's off, will it like reset the counter back to 0?
You will reset. Yeah, if that one is reset, this one will be reset.
Okay.
That means this guy will not. No matter how you press it, it does not work.
Okay. So that means like the counting, like the whatever value the count up is on, so like when the FCR is activated, it'll go back down to 0 or back to the default.
Yes, this guy will be deactivated.
Okay.
Okay, that's a good question. So if I give you the diagram, can you explain in the exam or in the quiz? And what I want to see is that I want to see, give me two case scenarios. If this guy is true, how each of these runs works. Right? If this, then tell me if this guy is false and how each of these runs works. I want to see the details. Thank you, Richard. So MCR, so this is what I just told you guys. And then we talk about the GMP and label. And you can see, look at the sign. The GMP is a parenthesis within the parenthesis. Parenthesis means output, right? If we have this is the square bracket, it's opposite, right? Square bracket we just did, but this one is opposite. So this is label. This is output. This is input. Use GMP output instruction, the input label instruction in pairs. The jumping forward to label and saves program and scan time by omitting a program segment until needed. If some conditions are met, here, and then you will not, then the system will not execute all these runs behind this run. It will jump to the label directly. So you can just skip some unuseful segments. It's a jumping backward lets the controller execute the program segments repeatedly. You can jump back. But make sure the label instructions is the first input instruction on the run. Do not jump into MCR zone. This is what I told you when we talk about MCR zone, right? If we have MCR zone, then and you need to use jump. Do not jump into MCR zone. Why? MCR zone, you will have a master control reset. If you jump into MCR zone, and the system will not follow your instruction. So here is one example, a jump. So this is jump, okay? So here is a jump. I jump, if this condition is met, the system will going to jump from here to here, this label. So it means that if this condition is met, all these runs will be skipped. You understand? All these runs located in between the GMP and the label will be skipped. And then this run will be executed next time. All these runs will be skipped. However, if this guy is false, if the system does not jump and they just follow the order of these runs and to execute each of them. Questions so far? And then we talk about the subroutine, SVR, and this is the return. They are used to direct the controller to execute the separate subroutine file within the ladder diagram and return the instruction following the GSR instruction. The subroutine is a function, as I told you guys. SVR instruction must be the first input instruction on the first run SVR in the program file that contains the subroutine. So this is SVR, right? Nesting of subroutines allows you to direct the program flow from the main program to subroutine and then onto another subroutine. So maximum of 8 nested subroutines. So this is just a recommendation. This is just a recommendation. If you nested too many subroutines, and you will have headache. So this is the observations of subroutines. Then we give you example. So here is example. This is example. So I think if we because we have already had our first PLC lab, and we know that at that time we use a main program, right? So you can write other programs. So here is the main program. So this is the main program run by run. Here, okay, if some conditions is met, I'm going to jump to the subroutine. What is the subroutine? So this here is a subroutine, and you can write a subroutine using the PLC in the diagram. So this is subroutine. Subroutine is the first run. Okay? This is the first run. So this is the last run of your subroutine. This is a function you want to repeatedly execute. As I said, if you use the subroutine or functions, whenever there is a need, you just call instead of put every statements for your purpose. Right? After this one is returned, it can go back to the next run where you just call this subroutine, call this function. You understand, everyone?
Yeah.
Subroutines, they are functions. GSR, jump to the subroutine. When the GSR instruction is executed, and the controller jump to the subroutine instruction at the beginning of the target subroutine file, okay, this is a file, and resumes execution at that time. And each subroutine must have its own program file by assigning unique file number. The allowed file number are 3 to 255. So keep in mind, subroutines are functions, and within the PLC context, a subroutine is another small program. We have a main program, right? And you can write a small program. This small program is called the subroutine. So here I'll give you one example. ESR RET return. So makes the end of subroutine execution or the end of subroutine file, it causes the controller to resume execution as the instruction following the GSR. Without RET instruction, the end instruction automatically returns the program execution to the instruction following the GSR. And for the very beginners, guys, I would suggest you use RET all the time. Okay, and just as for the C++, when you are very beginner of C++ users, I would suggest when you call a function, write a function at the very end, always write return. However, if you are a highly experienced C++ programmer, and you can just skip this, don't write the return. Make sense? So here, so this is the program. The program file, and for our case, we have the main program, and then we can create the ladder diagram. So we can create this ladder diagram 2 is the main program. And so here for other program, you can just right click new, and you can have new program. The program 3, okay, the subroutine, name routine, you can just write some description here. And for example, and the purpose for this program, and then you just click. If you click, and then you will see the interface that you can write new runs, just like when we write some other programs. So here is the program. This is the example. So this example, this is the main routine, ladder 2 main routine, main program. This main program, and for simplicity, we just have 2 runs. So if this condition is met, and then I'm going to jump to the subroutine and use 3, the subroutine 3, and then subroutine 3. So this second run, this reset and the production for the bit is unlatched. So this is a function. This is the instruction to call the subroutine. So here is a subroutine. Right? You can see the subroutine is a separate program. You understand? Here the subroutine is a separate ladder diagram. You can see if this condition is met, T1 is triggered, and so this T1 is the first timer, second timer, and third timer. And we have this is full output, and here we have so this is a reset, and if we click press this button, we can reset. So this is reset this timer 0, timer 1, and timer 2. So this is a program, separate diagram. Here we call this is the subroutine. So this is subroutine is a separate ladder diagram. So here is a refresh. The REF refresh instruction has no program parameters. And when it is evaluated as true, the program scan is interrupted to execute the IO scan and